So let's continue. So I already share a zip file into the WhatsApp group. So this one is on called as IPv6 GIE. So that is how we're going to define a GIE tunnel between the router 1 and router 3. Later I will show you the topology. So this configuration will be inside this step number 3 under IPv6 configuration command. How are we going to define the tunnel link? Either using GIE tunnel or V6 to V4 tunnels. So that is where we go through next. Let us go through a bit on the theory, how we define this. On this configuration of the GIE tunnels, what they are focusing into is to follow the figure shown into the network topology of the company A, complete the following configurations required. So I have router 1, 2, 3. Okay, router 1, router 2, router 3. So I have 1.1 running, 2.2, and also 3.3. Alright, sorry. So now we are going to go for the GIE tunnel configuration. So we have all the IPv4 is already defined. The information over here is see that the loopback 0, I have 1.1, R2, 2.2, R3, 3.3. So you can see that between R1, R2, R3, they are not running any V6 between. So this is V4. This is IPv4. V6 is only between from this point up to this point. So we're going to build the GRE tunnels. Okay, GRE tunnels from R1 to R3. So it means that from the source of 1.1 go to destination of 3.3. That's a tunnel how we're going to build. And under tunnel interface, this is the IP address. Okay, tunnel IP address and the loopback. So the method they're using over here is you can see that they're using 2001 colon. The first number is a router's numbers. Okay, for loopback 3 means 3. Colon 3 is also interface numbers. So you can see that from here. Let me just remove it. So this is 13 colon 3 64. So the 13 over here means that between router 1 to 3, 1 to 3. Okay, 1 to 3. So I have 13 over here. So this is like site ID between where to where, from router 1 to router 3. So I define over here as a 13. Okay, there is a diagram and what we're going to define on the IPv6. Yeah, IPv6 as well as the GIE tunnels, how they're going to communicate using the V6 over the V4 tunnel before I reach on the router 3. So IP address R1, R2, R3 shown in the figures, and their 3 devices are deployed in the area 0. OSPF V2, the configuration are complete. So this is already done on configuration. So all the OSPF IPv4 is already configured already. So what we're going to do, the required IPv6 address are marked that you need to define, and V6 over V4 GIE tunnel is deployed to implement the interworking between the loopback 1 interface of R1 going to R3. Yeah, R1 to R3. So how we're going to perform the GIE tunnels? By sending the V6 to V4 tunnels. Okay. And this is some of the basic configuration we need to know to understand this. Enter to system view, configure the tunnel interface, then set the tunnel interface to GIE, the source of the tunnels and the destination of the tunnel. This also as a V4 from 1.1.1 go to 3.3.3. Okay, from router 1. Router 3, the other way around. From 3.3.3 go to 1.1.1. Okay, and if you want to set the check on the GIE packet headers, you can using a GIE check sum. And also, let's say you're going to set the keyword of the GIE, also can set. This one is optional. And configure an IPv6 address on the tunnel interface. That is the one just now I mentioned, the 2001 colon 13 colon 1 64. So this is the addresses we define under the tunnel interface. Okay, that is a basic step we need to go across how to perform on the GIE tunnels inside the between the devices. Okay, between router 1 and router 3. So is everyone started already? Started the topology? So this topology is pretty straightforward. It's just only three routers. Okay, three routers. Okay, we need three routers. All right, I give you another 30 seconds for you to get ready all this. Okay, before I start the configuration. Okay, or you let me know. Let's say you are ready. Okay, so ready? So for defining the IPv6, we need to do it a step by step. So when configuring IPv6, the first step will be enabling the IPv6. Okay, enabling the IPv6. So how are we going to enable the IPv6 in this case? So it'll be pretty simple on the configuration here. Okay, they will just need to doing the IPv6. So that is enabling the IPv6 already. This is the first step to enabling the IPv6. When after enable IPv6, we need to configure on the loopback and also configure the tunnel interface. First, we configure loopback interface first. So they said that in the question said that go to the interface loopback one. Okay, interface loopback one and enable IPv6 enables IPv6 address 2001 colon 1 colon colon 1 64. Okay, this is what I'm going to define. And after you define, you can check display IP v6 interface brief. So you found that this address has been assigned into loopback 0. So let's copy into your configuration first. Okay, done? Okay. In this case, I'll go to router 3 as well, configure this address first. Okay, configure the loopback interface first. Interface loopback 1. But before that, you need to IPv6 enable first, and interface loopback 1, IPv6 enables, IPv6 address 2001 colon 3 colon 364. Okay, display IPv6 interface brief. Make sure your loopback 1 is up and running. Okay, done. Yes, any questions? Okay, so next step over here, when this V6 configure done already, we need to configure it on the tunnel interface. Okay, tunnel interface. So on tunnel interface, what you should do from here is, I was first going to this. Build the logical interface first. Interface, tunnels, 000. Another one. Okay, first, tunnel protocols. So the tunnel protocol, you can see from here, they have a GRE, IPsec, V4 to V6, V6 to V4, MPLS or none. So it depends on where they are located. So what is your middle one? You define is V6 to V4, with V6 V4 to V6. So in our environment over here is always V6 to V4. Using V4 as a base. Let's say V4 to V6 means that using V6 as a base, you are sending V4 over the V6 tunnels. Okay, so you try to make it as clear in this case. But over here, there's a description mentioned over here. So over here, first example I show over here are using the GRE. Okay, GRE tunnels. Okay, so it define the source as a loopback 0, destinations 3233. Okay, and the tunnel IP IPv6 enables IPv6 address 2001 colon 13 colon 164. Okay, so I will have what is my source destination, my interface tunnels, IP addresses, and what is my tunnel protocols. So that is all what I should need to define. Let's say you can't follow this, yes, I'll show you this over here. This is a configuration need to be done on the tunnel 00. So I will just pause a while for you to copy down. Okay, copy down all this information before I continue. Okay, done. So after this tunnel is been created from this side, you can also check display IPv6 interface brief. So you will see that your tunnel 00 is also up and up. Okay, physical is up and protocol is up as well. Okay, so do you see that? So the next over here is I need to do it on router number 3. Router number 3 is doing the same step as well. I need to build the tunnel 00 interface tunnel 000. First, tunnels protocols. Okay, tunnel protocol that I'm using over here is a GRE, and the source of these tunnels using the IPv4 are using interface loopback 0. Destinations is go to 1.1.1. IPv6 enables IPv6 address 2001:13:364. Okay, that's on the opposite. So display this. So let's copy this into your tunnel 00 first. Okay, done. So on this, you can check display IPv6 interface brief. So make sure the tunnel is up as well, and make sure they can ping to IPv6 followed by 2001:13:1. Okay, from router 3 can ping to router 1 already. Router 1 as well, ping to IPv6 2001:13:3. Okay, the tunnel is up already means that they can ping between router 1 and router 3. So that is where it comes from, how the tunnel is being built. Is it okay so far? But you can see that from here right now, on router 1, you can't go the loopback 2001:3:3 yet. So it can't go. Yeah, sorry. Ping IPv6 2001:3:3. Okay. Why it cannot ping? Because they do not have any communication between the router 1 and router 3 yet. Okay, so in this case, how are we going to perform in this case? We need to allow the connection from router 1 to router 3 able to ping across. So I set on the router 1 first. Okay, router 1. So how are we going to define? We do not using any OSPF ISS. We're just using the static route at the moment. Okay, using IP static route. So on router number 1, I set the IP route static. Okay, sorry. It's not IP route static. It should be, because it's running IPv6 route static. Okay. Destination is going to 2001:3:3 or ::64. And the next hop is going to the tunnels 00. So when you want to go to the destination of the 2001:3::, send the next hop to the tunnel 000. Okay, that's how I'm going out from my site to the destination. And same thing on router 3. IPv6 route static, then followed by 2001 colon 1 colon 64 and tunnel 000. So always you need to point whichever information going to the tunnels. Alright, and I go back to router number 1. Ping IPv6 2001 colon 3 colon 3. Okay, that's how you're able to reach to the destination. Go to destination by using the tunnels. But how I know that they're going through the tunnel from here is, let me just capture the Wireshark for you. Right click on the interface, start data captures. Okay, it's a PPP connection, it's okay. Okay, there is my Wireshark. So and now I'm going to just perform another ping one more time. Okay, I filtered ICMP v6. So you can see that whichever that I forward, they have a ICMP layer 3 IPv6 followed by the GIA tunnels. Then they go up to the internet protocol version 4, layer 3 for the IPv4 addresses. We have a source destination into the tunnels. Yeah, GRE and also v4. This is running on the GRE tunnels. Okay, GRE tunnels. What if right now I change another tunnels? You can change tunnels. Let's say that you want to. You can easily just go to the interface tunnel 00 and set that tunnels protocol IPv6 to v4 tunnels. So I change another tunnel. Display IPv6 interface brief. Okay, so you found that right now it's up and down. Why up and down? Because the tunnel protocol are not matched. So I need to do it on both sides. Interface tunnel 00, tunnel protocol IPv6 to IPv4. Okay, I set on both sides. Let's check again. Still down. When this you change the topology, you change the protocol, you need to redesign the source and destination. Okay, source is a loopback 0, destinations is 3333. Okay, same thing for this. Source loopback 0, destinations 1111. Okay. Okay, make sure it's up and up. So that's the configuration I'm modifying. After modifying, you need to redefine the peer again. Yeah, the peer again. We need to redefine one more time. Okay. So and this right now, I just try one more time. I do a ping again. When I open a Wireshark, scroll down. So this time you found that they do not have any GRE. They have only v6 and v4. V6 and V4 interface only. V6 and V4 headers only. Is it okay? For this is on the how the tunnels has been done from V6 going through the V4 network. So this is the basic V6 configuration. So later part when we cover on the routing protocol, we also need to grab the ideas of what are the routing protocol running on the IPv6, how the behaviors. Because into the lab exam, they also will test you about on the IPv6. But it's not that a lot of mark from that, but it's at least that you need to grab the ideas how the IPv6 has been done, how to be configured. Yeah, all this you need to grab the ideas. So any questions so far?
No.
All right, thank you. Okay, I will just stop for this. Then we'll for the IPv6 so far okay. Then I'll go for the next one. That is how you configure on the GIA tunnels. And the last one over here is suggestion for the IPv6 exam preparation. So what you should get ready for the preparation of the IPv6 into the exam, and you need to get ideas about on the have a good command of the IPv6 protocol command. So what I showed just now, what we need, what we required. So we need to always globally enable first, okay? Enable globally after that, enable on the interface and configure from the interface. Okay, that is on the step by step. And make sure that whichever things that you did done is need to do it under the IPv6. Okay, when you check display, you display IPv6. Okay, you're going to display IPv6 followed by the uh, interface or brief and so on. So you need to do it under IPv6. From V4, you change to V6. That is where we go up to. Okay. Then you also be familiar with the implementation and application of the IPv6. Familiar with all the policy tools such as IPv6 and also check the headex document and understand the case scenario design into the course that I explained just now. And make sure that into the exam, into the real exam for the HCIA exam, you're able to open the headex. For the lab exam, you're able to open up the headex and to check, let's say the command that you do not know, you always can be refer back based on the headex. Headex they provide based on they provide a router headex, a switches headex. They provide two different headex to you. Okay, and also this recommendation on the website you can go across, and also the case library. That is for the IPv6 basic principle that I covered for today. And the next one that I going through will be on up to the next protocols already. Okay, let me just open up the next protocols. So before I continue on this, let me just capture the attendance. Okay, capture attendance. So next is on the OSPF. OSPF, I think that HCIA, HCIP have been covered already. So for this HCIE, RNS, OSPF topic, we are focusing more into the IPv6. So what is added into the IPv6 on the OSPF? So OSPF v6 requires a OSPF v3. So under here we have two versions. We have OSPF v2 and OSPF v3. Okay, so v2 is purely for v4. Okay, that is for IPv6. Okay, so they're going to carry on a different SLA to cater for the OSPF environment. Okay, but at the beginning, for sure, need to go through a bit of the basic OSPF v2 first. Just give you some recall what we learned on the OSPF v2. Okay, OSPF v2, OSPF is stand for the Open Shortest Path First, the OSPF. They're developed by the Internet Engineering Task Force. It's a link state interior gateway protocols. It belongs to one of IGP. They're using the link state algorithms, and they provide the fast conversion, loop-free routing, high scalabilities, and also it be very widely used. Okay, it's widely used. OSPF. ISIS will be more into the service providers. OSPF will be more popular into the enterprise environment. In this case, for this objective, we need to understand about the OSPF fundamentals, improve your OSPF fault troubleshooting. Just bear with me a while. Let me just stop the timers. They keep on shifting. Okay. So first you need to understand the OSPF fundamentals, how about the troubleshooting capabilities to improve that and enhance the comprehensive capabilities of the OSPF, and understand the OSPF v3 fundamentals, understand the difference between OSPF v3 and the v2, what's the differences, okay, and understand the OSPF v3 configuration, method, and the command. Okay, that is what we go into. So far, okay. So this is what is the objective we want to achieve when completing on this topic. Okay, OSPF. So next on the OSPF v2 basic concept and also the features. So I'm sure that every one of you should know that what is on the OSPF v2 on the basic concept. So basic concept of OSPF v2, we know that there is on the fast conversion, they have a loop prevention, and also they can be have providing the shortest path tree, specify the best path to the destination, and so on. That's all we know. Okay, but I think that in the HCIP as well, you also know about in the OSPF v2. So they're going to come up with the different type of LSA. How many LSA that you know in the HCIP? How many LSA that you already known that in the HCIP? So what we know is on the LSA, type 1, type 2, type 3, type 4, type 5, and type 7. Am I right? This is what the commonly used into your HCIP environment. So we know that type 1 and type 2 is belong to intra area. Okay, for 3 is for inter areas. 4, 5, and 7 is for external areas. Okay, so that's how and where they come from. Hopefully that all of those you still remember about all the LSA that we cover on the HCIP. Okay, but never mind. Let's say you some of them you forgot already. We also be going through on this LSA type. We need to go through a bit. What is the LSA that we have? We have type 1, type 2, type 3, type 4, 5, and 7. But into this, we're going to introduce that we have another one is called 9, 10, and also 11. 9, 10, 11 will be introduced into this OSPF v2 as well. So for the page over here, next page over here is talking about on the LSA type. So what are the LSA type that we have? We have type 1, 2, 3, 4, 5, 7, 9, 10, 11. So for type 1, type 2, it be straightforward that you need to know that type 1 is belong to a router LSA. Who own this router LSA? What is information inside the router LSA? What is inside the type 2? So you need to grab the ideas on all this information. So from here, let me just add a single slide for me to draw. Okay, I will show you the diagram from here. So I don't have any press book for his CIE actually. Um, I think that some way they should have this. Last time they do share on the version 1. Last time they have version 1, they share a book. But for the press book that what you mentioned, actually everything is still can get from the headex. So headex, inside the headex, they still have full of all the information, but you need to know how you get this information from. Okay. So normally when I do not know certain function or certain features, I always refer back into the headex. That is where the way that you can refer back. Let's say you have any question when you do your self-study, you have any question, you always can refer back to the headex. Otherwise, you can just drop a message into the WhatsApp group. Then where I can respond back to you. I can explain to you what is the question that you ask. Okay? But they do not provide any press book for this HCIE version. Okay. Hold on, let me just do this. All right. So from this LSA type I did show over here, I need to draw some diagram from here. So first, we know that we have a type 1, type 2, type 3, type 4, type 5, and type 7. So in what type of situation we're going to use this type 1, 2, 3, 4, 5? So I just using one diagram just to explain to you what we should use to perform all these different type. Okay, so it's just a simple one. I show you how you perform that. All right. So first, from here, I'm going to have a routers. Let's say I just draw this is a routers A connecting to router B. Okay, connecting to router C. Connecting to router D. So I have 4 routers A, B, C, and D. So router A and B are using Ethernet. B and C are using a PPP connection, and C and D is running on the Ethernet. So far, okay? That is how the connectivity is performed from here. So first, we need to know that how many area they divided from here. Let's say right now, I will just put the information from here. I have a 1.1.1.1. This is a 2.2.2.2. This is a 3.3.3.3. And this is a 4.4.4.4. Okay, this IP addresses. I have a 12.1.1.0, 23.1.1.0, 34.1.1.0. Okay, so I group them. So over here, so I have area 0, area 1, and area 2. Let me just assign this. Okay. So in the middle over here, I have a area 0. This is a area 1. And this is a area 2. Okay. So when you know about the area, you should know about all the database information that you should know from this. So in this case, every single routers they're going to be generating the database. Okay, let me just write it down from this. On router A, okay, router B, router C, and router D. Okay, I have A, B, C. Router A, you should have a area 1 LSDB. Router B, you have area 1 LSDB, and also area 0 LSDB. Router C, same. I have area 0 LSDB, area 2 LSDB. Router D, you have area 2 LSDB. Okay, this is all the database that you should have between on the different areas. Alright, so in this case, I will just fill up the information. Let me show you that there are different LSA. So I'm using different colors. Okay, this is a LSA 1. Yeah, so I'll show you the 1, 2, 3, 4, 5 first. So what's the difference between this 1, 2, 3, 4, 5? So for 1, 2, 3, 4, 5 that I have, this is type 1, type 2, type 3, and 4 and 5. So I need to differentiate how it can be done on the area 1, area 0, and area 2. So first, under area 1, I'm going to talk about area 1. So first, we're going to go through the first second. First second is on the intra area. The third is on the inter areas. And 4 and 5 is on the external areas. So the first one, LSA type 1, everybody is generating. All the routers you generating the type 1 to tell that what advertising into your areas. And I'm using the router IDs. My router ID is a link state ID, okay, as information that I want to send, okay. So it means that these directions I will send and send. That is a type 1 I will send. So what I'm getting on type 1, so I will going to keep this information over here. I will say that I will get this router A, LSA, type 1. I also will get a router B, LSA, type 1. Same case for router B. I have a router A, LSA, type 1. LSA, type 1. Okay, that is the information I should receive. By right, I should do it like this. I should better just using these addresses. So I show you as a link state ID. So router number 1, I have 1, dot 1 dot 1 dot 1. Router number 2, I have a 2 dot 2 dot 2 dot 2. Same case to this. Between area 0, they have their own as well, router B and router C. And the area 2, you have router C and router D. So you should have C, 3, 3, 3, 3, 4, 4, 4, 4. Okay. So this is on the type 1. Type 1, everybody will be sent within their intra areas. So next will be on the type 2. What is the type 2 here? LSA type 2 is only generated by the DR. Whoever is the DR will send as a type 2. In this case, area 1, I have a Ethernet. When Ethernet means I have a DR. But area 0, I have no DR because area 0 is just a Ethernet network. Okay, Ethernet network. For area 2 as well, is on the Ethernet, so I'm going to have a DR on this section. Okay. So how are we going to define in this case? So first, on the area 1, I need to check. Router A or router B become the DR first. So let's say router A is a DR. This is a DR. I will only send this LSA. When router C as a DR, I will send this LSA type 2. So in this case, I will send that is from A. There is a 12.1.1.1. You will send within your area, intra areas. So this router B area 1, you will keep this 12.1.1.1. Same case to router C area 2. I have C 24.1.1.3, C 34.1.1.3. Okay, that is what they're getting from the type 2. So far, okay for this type 2. Yeah, 1 and 2 is alright, so far. Alright, next is the LSA type 3. Okay, I'm using another color, light green, okay, as a type 3. Okay, type 3 is meant for the inter areas. From one area to another areas. Okay, it's inter areas. So it means that they're going to doing the translation of the type 1 to type 3. Okay, so who can perform this translation? It have to be done by the ABR. Okay, ABR. Only ABR are doing the translation from type 1 to type 3. Means that whichever that you send as a type 1, when you're passing through another areas, I will generate it as a LSA type 3. Okay, that is what they send as a type 1 to each other. Okay, the type 1 they send to each other. When I have type 1, I will translate it to become type 3. Same thing to this. Okay, this is what the translation it can be done from 1 to a 3. Okay, type 1 to type 3. So it means that the result you'll be getting from like this. So mainly it starts from ABR, router B and router C. So whichever type 1 that I have, these two will be generated to here. Okay, these two will be generated to here. Okay, vice versa. Then how they're going to exchange in between. Okay, let me just. And this information they're going to show So in this case, I'm going to have a router A. I have 1.1.1.1. Router A, I will have 12.1.1.0. Okay, this information they are collected, and also router B, they have a 2.2.2.2. So for LSA type 3, it's all the detailed information. I have 1.1, I have 12.1, okay, 1.1, 12.1, and the 2, sorry. 2.2.2.2, this one is not. For this example, on this, area 1 to area 0 is only 2 physical. So I have 2 detail from here. When the other way around, from area 0 back to area 1, then they have more information to be converted. Okay, so from here, I will have this. Router B, I have 2, 2, 2, 2. Router B, I have 23, 1, 1, 0. Router B, 3, 3, 3, 3. Okay, this from router C. Okay, that's what I'm getting. So that's what they interchange from type 1 to type 3, type 1 to type 3, and vice versa. So whichever I have from here, I'm going to share back into my intra areas. So from here, whichever on the router 1 it should receive 2, 2, 2, 2, 23, 1, 1, 0, and 3.3.3.3. So that's the information I will collect it under A1, okay, area 1. Same case on the router C, okay, router C. So in this case, when it's intra area, this will be synced as well. I will have this 1.1.1.1, 12.1.1.0. This also be sent to the router C. Type 3 also get to type 3, and the type 1 will be type 3. They were allowed to send type 3 as well as they're going to change from type 1 to type 3. That is what they are performing. So from here, on the router C area 2, that's what I'm getting from here. I'll have this. I will get the 2.2.2.2, 23.1.1.0. I also will get the 3.3.3.3, 12.1.1.0, and 1.1.1.1. Okay, so that's be pretty a lot of information inside. So they're going to exchange from C area to area 0. They should be synced as well. Okay, so in this case, they will have a 34.1.1.0 and 4444. This will be synced. Okay, this also will be forwarded. Same as RTA as well. To tell that this is all learned from the inter areas. Okay, inter areas. So that's how you're getting this information. And this also synced to router D. Router D will learn everything that is sent by RTC. Because remember, all the database must be synchronized. Okay, that's how they are fully synchronized the information. So the first color, purple color, is for the intra areas. The blue color also for the intra. The green colors is for the inter areas. So it means that for router A know how to go to 2.2, this is 2.2. Okay, there's other areas. 23, 3.3, 34, and 4444. Okay, how they translate this information? They are done using the ABR. It's ABR who doing this translation. Is that okay? How this translation is being done? Okay. So this is on the type 3. So for type 4, LSA number 4, and number 5. This is only happen when you're doing the import route. Okay, import route. So let's say right now from here's import route. Okay, I will have address of 100.1.1.1. Okay, 32. This import to OSPF. Okay, import to OSPF. When import to the OSPF already, they will generate the type 5. Type 5 is using this color. Let me use a color of this. Okay. Okay. You have the externals over here. Inside the externals, you should see this is 100.1.1.1. Okay. Same thing, 100.1.1.1. Okay. For this .1.1.1, they will tell that who are the one who sent this information from. Okay. It's sent from the router D. So they're going to say that this is router ID from the 4, sorry, 4, 4, 4, 4. 4.4.4.4. So they know that this is come from 4.4.4.4. Okay. Each of the type 5, this is type 5. They will tell that, oh, this is the destination from the external environment come into the OSPF. They're going to have separate database, and they do not specify this database is belong to area 1 or area 0. They're going to using their dedicated database just for the external route. So, and the last one is on the type 4. Okay, but before that, when this imported already, they're going to be generated as a type 5. When type 5 all the way go up to the ABR, pass through ABR, okay, then they will generate it, okay, generated as a LSA type 4. Type 5 is to tell you that what is the destination. Type 4 is just to tell you that who is the ASPR advertising this information. Okay, type 4 is to tell who is your ASPR. So in this case, within the area 2, they have nothing. They have nothing related to the type 4 because it's inside the intra areas they are advertising. Only when they pass through an areas, like when this information RC as the ABR they created already, I will generate a type 4 from here to set that to go to 4, 4, 4, 4. Send to 3, 3, 3, 3. So I create a type 4 to tell that this is the ASPR. When you want to go to this ASPR, you send to me. I'm the 3.3.3 for you to go to the destination. Okay, so it means that I'm the ABR for you to reach to the ASPR. Okay, same thing to this. So this information you get from here as well. 4444 3333. Same to this. Okay, so from area 1 go to the ASPR, they pass to the ABR of the router B. Okay, when area 0 go to the ABR, they pass to the ABR for the router C. So it depends on where you come from, which ABR advertising this type 5 to you. So I'm going to generate the type 4 and pass to you for you to access to the destination. Okay, that is a general explanation on the LSA. So we have intra areas, we have inter area, we also have a external areas. Okay, intra, inter, and external. So always remember on this how the differentiation between the LSA. So the most important LSA actually is only three LSA: Type 1, Type 3, and Type 5. Type 1 is your intra areas, what you're advertising internally. Type 3 is between the areas. And Type 5 is all the external come to your OSPF. So these are the three LSA is important. Type 2 is not important. Type 2 is just to tell that who is your DR. Type 4 is important, is to guide how you go back to the ASBR. Okay, it's a guide how to go back to the ASBR. So actually, the information, route information will be forwarded using Type 1, Type 3, and Type 5. Okay, 2 and 4 just to tell you that who is a DR and who is a ASBR. Okay, that's it. Okay, that's it. So far okay. So for the LSA, any questions so far? Or up to this point, every single one is still okay? Well, this one is just refer back what we going through on the HCIP actually. Okay, but you should already grab the ideas when we touch on the HCIP. So the difference over here is that one is called the NSSA, the Type 7. For this Type 7, it's just that they are under on the NSSA, a non-so stubby areas. Then you have a Type 7. Other that, they will not see this Type 7 actually. Okay. So this one is to describe the destination outside of AS. So it means that first you generate as Type 7. From Type 7, go for back to the Type 5. And Type 5, you can have see the Type 3, Type 4, and Type 5. Okay, that is on the NSSA. And for the OPEC LSA, Type 9, Type 10, and Type 11. Type 9 LSA is more for the grateful restart for the GR. Type 10 is meant for the traffic engineering, okay, TE. And Type 11, at the present, there are no application is running yet on the Type 11. They're only running on the 9 and 10. So when we're doing the OSPF traffic engineering, we need to enable the OPEC LSA to support the Type 9, Type 10, and Type 11. Okay, when it has enable OPEC, automatically they enable 9, 10, 11 already. Okay, these are the LSA type they need to know very well that how this is being performed, how they're going to be interchange the information. Okay, you cannot miss out any information from here. You must make sure that you understand 1 and 2 is intra, 3 is inter, 4, 5, 7 is externals. Okay. For a Type 9, Type 10, actually it's just for the traffic engineering. Okay, that is on the MPLS traffic engineering. Then only using this OSPF TE. But for this exam, they will not cover anything on the TE. So we do not really go into this. Okay, so we focus also back to the 1 to 7 only. But definitely into the LSA on the OSPF V3, you still have OSA. LSA we need to be remembered. Okay, they have another range of LSA under the OSPF V3 as well. So far for OSPF V2 LSA, it's all okay. I said okay, I go for the next one. The next one over here is called as a router type. What are the router type that we have? Okay, router type in the inter areas is straightforward. But when you import from the externals, they will define to the Type 1 external route and Type 2 external route. So we have Type 1 route and Type 2 route. So by default, OSPF are using a Type 2. So what's the difference between Type 1 and Type 2? Type 2, always they'll prefer based on the, they will default, then they will just prefer what the cost that you import into the OSPF. And after you import it already, you will not see any incrementals of the cost. the cost will be all the way will be the same as the cost of 0. Okay, cost of 1, sorry. Cost of what you import into the OSPF. Okay, type 2 route have a low reliabilities. Means that when you have type 1 and type 2 together, I would prefer type 1. Type 2 is not preferred. Okay, OSPF consider that the cost of the route from the ASPR to destination outside on the AS is much greater than the cost of any internal route to the ASPR. So cost of the type 2 equal to the cost of the route of the ASPR to the destination. So it means that whichever you import, when you import is the cost of 2, I don't care how far away you go, the cost in total is just cost of 2. It's not increasing anymore. Okay, only up to cost of 2 only. But for type 1, the cost of the route from the device to add the ASPR plus the cost of the route from the ASPR to the destination. It means that they will accumulate the cost from the destination all the way back to the source they want to reach. Okay, that is called type 1. So type 1 and type 2 always prefer type 1, but the default as a type 2. Type 2 as an external type. So far okay? For that is on the route type. One and intra and inter is nothing. Okay, that only intra is always a prefer. This is the first prefer, second prefer, sorry. Third and fourth. So when you have intra, inter, external route, they're going to the same destination, I will prefer using the intra area first. Then only go for the inter area. Last, go for the external areas. So okay, that is how they are divided between the priorities, the preference. Which one you come first? Okay. So far on the route type, any questions? No problem for the type. And next on the basic concept of the OSPF v2, the option field. The field of the option you need to know. They have 8 bits. 8 bit into the option field. 8 bit. For this 8 bit, you need to know how they're carrying on the information. They can carry it through the hello bucket, DD bucket, and all the LSA. So option field, they need to be compared, need to be matched every time they send the information to the peers. Regardless they send a hello or send DD or send LSA. This information needs to be matched. Let's say it's not matched, then in this case they may have an issue already. So in this case, in this 8 bit, what are those 8 bit of the flag that we have from here? The first one is on the DM bit. This DM bit is only happen when you're running on the MPLS, BGP, VPN, and your base are running OSPF. Okay, requires the OSPF VPN. Okay, then you have a DM bit. This DM bit is to have loop prevention is supported inside your VPN environment. Because inside the MPLS environment, you will have area 0. You have multiple area 0. The area 0 inside the MPLS domain requires a super backbone. But this one is not into this topic. So I will not go more in depth. So when you go for the carrier IP, then they will go more in depth into this. What is meant for the OSPF VPN. But this is one of the bit for us to doing the prevention of the loop. It's called DM bit. The second one is an O bit. OPAC. The OPAC LSA supported, it means that they support the 9, 10, 11. The OPAC LSA 9, 10, 11. So let's say you want to go for the MPLS TE, that is the things you need to enable. You need to support on 9, 10, 11. Next is on the DC. DC is more to the on-demand link. On-demand link. So on-demand, it means that, let's say right now, I have 2 links connected to my OSPF. Okay. throughout the WAN connection. Okay, throughout the WAN connection. But the link that over there is need to be paid when I send any traffic. So we know that OSPF will keep on sending hello every 10 seconds. So in this case, it means that I will keep on being charged by the utilization. So in this case, what you can do, you can set that link is on demand. I will not tear down the peers, and also I will not send any hello. Only I need to use that, I will send the hello. It's only on demand. When not demand on that, I will just keep quiet and keep the connection. I will not do any information. Only when I need that on demand, I want to send this information out of that link. That is called on demand link supported. Okay, it's a DC. And the EA is to extended attribute LSA are supported. This one is to supported LSA type 8. Okay, this one is more into the IPv6 multicast they've been using over here on the EA bit. Then for the NMT, this is more into the NSSA. Okay, NSSA for the type 7. When you are using NSSA, you should see the bit over here is 1. MC, this is on the multicast. Okay, multicast OSPF is supported from this case. The E over here is on the external route, the type 5, LSA type 5. And the MT is called multi-topology is supported. Okay, multi-topology. How are you going to combine a V4, V6 together? Is support on the multi-topology. Okay, it means that it's multi-process in this case. So these are the option field inside the basic concept that we have. Yeah, inside the basic concept. So far, okay or not? For this 8-bit. But the most commonly used will be on the, these are the commonly used. You found these two. N or E. N bit and E bit. The rest, seldom you will see that is set. So that's why I'm not sure that you still remember that inside the OSPF establishment, then when you form the hello from the DD, LSR, LSU, LSX, inside the hello bucket, they need to match 5 information. Okay, there must be same areas. Okay, same network segment, same authentications, same timers, and the last one is the same options flag. This is option flag that I mentioned from here. This they need to match the N bit and the E bit. So E bit they have a 0 or 1. N bit as well is a 0 or 1. So when this is 1, it means that they have LSA. When this is 0, it means that they are running as a stop. When this 0, it means that they're not using NSSA. When it's 1, it means that they're using NSSA. So this is under the stop flag, or we call it as a stop. Okay, the stop flag to identify either we are inside the stop or inside the NSSA or inside a common areas. So that is where they can define. That's why they have one option to manage the option flag. Make sure they are matched the same flag before they can proceed. Okay. Before they can form the neighbors, they must match all the 5 information here. Okay, this is on the option field. So the next one is on the convergence features in the OSPF. OSPF is support on the fast conversion because they're using the ISPF, incremental shortest path first algorithms. So they're going to perform the full calculation at the first time. When the first collected already, I do a full calculation. After that, I only calculate the affected node. Affected node over here means that, let's say I add a new routers. I only affected the node that I added in. I will not affect the rest anymore. Because the rest I already have a first calculated already, then the rest is just a incremental information need to be calculated. So far, okay? That is what it means from this ISPF. When you add a new routers, I do not need to calculate entirely. I just calculate into the to that routers only. So far, okay? Okay. Sorry. So this on the ISPF. The next one we look into this is on the PRC, partial route calculation. Okay, partial route calculation is to perform the route calculation only for the change route. This is difference between the node. Node is add a new routers. A route, let's say you add a new route or you remove the route, that is a route, the IP addresses. They only define the calculation to the change route only. So update route based on the shortest path tree calculated by the SPF. So they always refer back into your ISPF algorithms. Based on that, I perform the partial route calculation. I will not do everything is full calculation, only partially. Okay, that is the two things. And the next one is on the intelligent timers. Intelligently control network instabilities such as those caused by the interface flapping to reduce the LSA flooding. Okay, let's say sometimes when your link is flat, when you're up and down, it means that when up and down, I need to send LSA. It come back already. I need to send LSA for them to recalculate again. But let's say go down again, I will go to send one more time. When go up again, I send one more time. So how frequent you send, in this case, you keep on sending and sending and sending, you'll be increase your burden of your resources, your CPU resources. You keep on have a burden. So they're going to keep on process and process the same information. It's just because of your interface are flat. Okay, so to reduce this type of the flapping, you can set the intelligent timers to set that, oh, when we in this period of time, you are keep on need to send and generating, I'm going to set that, hey, hold, I do not need to send first. You are flapping right now. I do not want to handle your information. I do not need to calculate your LSA first. Because right now your link are flapping. You keep on sending to me. Let me wait for expiry first. I will have a timer. This timer is be intelligently increased by themselves. So that, okay, right now I will just keep quiet. I don't do any calculation for yours. Only after, until the expiry of the timers, okay, I deal with you. I send. Let's say keep on flap again. Okay, I will going to hold again. I do not immediately calculate whichever is sent to me. So this is what we call as an intelligent timer we can provide to handling between the flash flooding. How are you going to flash flooding of our LSA information to the next devices? Okay, this is how we're going to do the handling. You can enable the intelligent timers. And the last one is on the priority-based convergence. Okay, priority-based convergence is allowed the route with the higher priority to converge first. Okay, means that everything that you learn or you advertise, you can set the priorities. You found that this is important. You need to be converged first. When anything come back, go down and come back again, you need to allow this to be first. Then you can set the priorities. By default, everything is under the medium. You can make it to the high or to the low. Okay, to set the priority of every single route that you advertising or whichever route that you learn. You also can define the priorities. What should be calculated first? What need to be calculated first? You can set as a priority to the highest. Okay, that is on the priority-based convergence. And the next one is on the database overflow. So you can set the maximum number of the non-default external route on the routers can prevent database overflow. Okay, All routers of the OSPF must be configured with the same upper limit. Set the limit. What the limit I can handle for the non-default external route. If the number of external route on the routers reach up to the limited, the routers enter to the overflow state and start to an overflow timers. And the routers will be automatically exit the overflow state after the 5 seconds by default. Okay, when they're up to the limit. When they're up to the limit, what they perform? When up to the overflow state, it delete all the local generated non-default external route. Okay, they were going to delete whichever that come in from the route import. Okay, when come in, because it could be a lot of information come generated from here. So I'm going to delete whichever is not my generated, not my self-generated. I'm going to delete everything to make sure that my database is not being overflowed. So from the router 4, in this case, they have no more routing entry can be stored when the number of route entry up to the upper limit. So you cannot gather any new information. Because of, let's say you have mystically defined the import route, you import too many route into OSPF, your database might overflow. When overflowed up to the certain limit, they will just go to the overflow state and delete all the non-default external route. Okay, in this case, they're going to be clear up their database. Okay, clean up their database to make sure that I can support all my inter area first before I handling the externals. Okay, that is what the database overflow they're talking about from here for the OSPF version 2. And next one is on the OSPF v2 default route. Okay, default route. So under default route, we divided to a common areas, stub areas, totally stub areas and necessary areas, and the totally unnecessary areas. So common areas means that a normal non-backbone areas is called as a common areas. Okay. When you want to have a default route under common areas, you just have to advertising the type 5. Type 5 LSA and advertise into the entire OSPF AS. Okay, entire areas. Except the special area in the AS. The special area is meant that the stub, totally stub, unnecessary or totally unnecessary. That is called the special areas. For the stub areas, an APR automatically generate a default type 3 LSA and advertise to entire areas. Okay, default, that's you do it automatically. But the first one, common, you need to do it yourself. You need to generate it yourself. So under the common areas, when you advertising default route, they have two methods. They call as a default route advertise and also default route advertise always. So that is a two-way for us to generating the default route into the OSPF. So what's the difference between these two? What's the difference between these two? So the difference between these two on the default route advertise and the always, on the advertise, you will just say that make sure that my routing tables have this, I generating the default route to you. Okay. For always, I don't care. I will just creating default route to you as long as I going to send, as long as I have a configure the always keyword, I will always send a default route back to the OSPF areas. Okay. So far, okay. So something like this, when this one, the first one, my routing tables, you must have a default route, something like this, based on other protocol like BGP. When I have this routing default route in my routing tables, then I'm going to assign a default route to my downstream using the type 5. Okay. For this, I don't care. Even I have no default route in my routing tables, I was generating a 0, 0, 0, 0, 0 to OASE. Okay, that is what I'm going to be performed. Okay, on the routing tables. So far, okay. Any question on these common areas? Okay, so for stop, totally stop NSSA and totally NSSA, then everything will be doing on the automatic generated on the type 3, NSSA type 7, totally NSSA is on the type 3. For NSSA, they have one is a manual configured on the ASBR. Let's say under ASBR, facing outside, you want to generate another default route, you need to do it manually. Okay, you need to do it manually to assign the type 7 LSA back into your entire NSSA areas. Okay, by default, ABR will automatically generate it. But for ASBR, you need to point a default route going up, you need to do it yourself. Okay, point a default route, go to the other environment. Then you need to do it yourself by using the similar to the common areas. Okay, just default route advertised, but it's a type 7. Okay. So far, okay. This is on the default route advertising on the OSPF v2. And the next one is on the route filtering. Okay, on route filtering. Under route filtering, we have a filtering of route to be imported. Okay, under LSSA and also under the route. So they have LSA route or the LSA or not non-LSA. Okay, filter route to be imported or LSA filter into OSPF process view. They filter type 3, type 5. Okay, LSA filtering is always type 3 and type 5. There can be filtering in between. Okay, so LSA filter in the OSPF process view, type 3 will be learned and advertised, type 7 will be on the generated and type 7. This one, type 3, we always do it under which routers? We do it on the ABR. Let's say I want to filter a type 3 LSA, always filtered under the ABR devices. When you want to filter type 5 or type 7, you do it under the ASBR. Okay, ASBR is to filter the type 5 and type 7. So LSA filter into the interface view, that can be also done on the process or do it on the interface. Okay, filter of the route can be calculated. Okay, to be calculated. So it means that I normally for we filtered, remember, in the OSPF we have a route, we have a LSA. LSA flooded to everybody. Route is only calculate yourself. Okay, this is only the routers. This is everybody's. Okay, everybody will get the LSA. So when you want to filter, you better filter LSA, but not filter route. But if filter route, you only filter yourself. You cannot say that this route I do not want to send to you. You can't, because by default LSA is start to flooding to everybody already. Okay, because the route is based on your own calculation, your self calculation of the route. But LSA it be flooded to everybody. So you only can say that this route I do not want to calculate on my side. I do not want to calculate the route on my side. So I'm using the route. Okay. Filtering of the route to be calculated, OSPF filter the LSA in the database when calculating them as a route. So I can say that when I receive the LSA, I will say that this route I do not want to calculate under my database. So only affect yourself, but not affect the rest. Okay. Only the route that calculated through the SPF algorithm are stored into the routing tables. The LSA used for generating the route are flooded into the OSPF. Okay. Oh, sorry. Give me a second. I have a call coming in. Right, sorry about that. So I have a one call coming in suddenly. So let me continue on this. So for the route and LSA are different. LSA, it be always everybody will getting. When I flood all the LSA to the peers. Okay, route you can filter what they can calculate yourself. Okay, this is what it said. Only the route they calculated through the SPF algorithm are stored into the routing tables. When you filtered, means that you will not do any calculation on that information. But for LSA, are still generating the route and flooded all to the OSPF AS. Okay, so you need to know what you are filtering. You filtering on the LSA or you filtering on the route. So in the OSPF, especially OSPF and ISIS, they are more focusing on the LSA and LSP. They are not share the route information to you. They send the link state information. Okay, they do their own calculation. You cannot force that I do not send this information to you, because the first requirement under the OSPF or ISIS under link state algorithm, my LSTP within a single area, they must be synchronized. The LSA must be synchronized, okay, between the device within the single areas. That's why you can't perform just filtering of the route. We have to filter either LSA, type 3, type 5, type 7. Route, you can only filter yourself. Okay, filter what route you not calculate by yourself. Okay, OSPF filter the LSA database when calculate them as a route. So it means that I will ignore this. I do not calculate this into my database. So far, okay? So on the LSA filtering can be done on the OSPF view, also can done it on the interface. So it is up to where you are defining. So I think that this also is been covered when you touch on the HCIP already. Just give you some ideas on the LSA filtering already. Okay. So far, all right, for this route filtering, can you differentiate what is the type 3 and type 5 and type 7? That's why when we're doing this filtering policy, we're filtering like this: filter policy. They have an import. They have filter policy. They have export. Okay, import and export. Okay, filter policy import, it means that they always do it on the ABR. Filter policy export, you do it on the ASPR. Import means that they're going to filter LSA type 3. Export LSA type 5 and type 7. Do it under ASPR. Okay, that is what you can perform. You only can do it on the ABR and ASPR. Let's say you want to do it on the IR, the internal routers, you can only filter policy import. Okay, only whichever come into you, you can filter. You cannot filter outgoing. Okay, you can only filter import, but not outgoing. This is filtering route. Okay, by under IR routers, filter policy import is filtering the route. Under ABR, filter policy import is filter LSA type 3. ASPR, export, filtering type 5 and type 7. So you need to grab this idea first, because into the exam, that is what they will ask you to perform the filtering, either on the route filtering or LSA filtering. So you need to know where you should apply this filtering into, either into the ABR, ASPR, or into the IR. Okay, IR, route filtering. ABR, ASBR is a LSA filtering. Is that okay so far? For the route filtering on the OSPF version 2. And the next one is on the comparison between the OSPF and ISIS. So for this comparison for OSPF and ISIS, I think I will leave it for tomorrow, because another 5 minutes, I don't think I can cover everything. Because tomorrow you still have another day just purely covered on the OSPF, and also perform the lab on the OSPF, including the OSPF V2 as well as the OSPF V3. So that's what we're going to going through on the configuration. So tomorrow can consider entire day is on the OSPF. It depends. Maybe we also will include the ISIS as well. Okay, because this is all the protocol we need to focus into, because that is where the most of the point come from your IGP, come from your BGP, and come from your MPLS VPN. Okay, this is where the mark is come from. That's why we need to focus more into this part. All right. So far for this OSPF fundamentals, for the basic concept and the features, is it all right for today? And before everyone leave, let me just capture another attendance for today's first. I forgot already. Okay, let me just capture once. Okay, so far everything is okay. Any other question related into the OSPF? You can do some revision on the OSPF version 2, because for this we'll more go to version 3. But let's say you still have any question on version 2, is okay, you can ask tomorrow, because from tomorrow we're going to start to understand about the version 3 already. What type of LSA they're going to send under IPv6. Okay, so I'm going to stop here for today, and I will continue tomorrow. Okay, tomorrow 9 o'clock I will continue with the OSPF. All right, thank you everyone. So I will see all of you tomorrow 9 o'clock. Thank you.
Thank you, Nick.
Thank you.
Thank you.